Hello, this is the video corresponding to Chapter 4, Section 4.6, Basic Sentential Logic and Informal Fallacies, textbooks used for Philosophy 10, Introduction to Logic at UCSD. The topic of this is just one topic, which is conditional proof, or I'm sorry, indirect proof. So indirect proof, it's one of two proof strategies. The other one we introduced in Chapter 3, which was conditional proof. This one, indirect proof, is similar in a lot of ways. It also involves making a subproof where you start with an assumption, you end the subproof, and then you're using that subproof to derive some specific statement. Remember, with conditional proof, you would assume the antecedent of a conditional, derive the consequent, close the subproof, and then that's how you derived the conditional. In indirect proof, what you're going to do is the following. What you're going to do is derive a statement phi, and it can be any statement. It could be an atomic statement, it could be a conditional, it could be anything. So this is one difference between indirect proof and conditional proof. With conditional proof, you could only directly derive a conditional. Indirect proof, you can directly derive anything. So phi, you want to derive phi. How do you do it? You do it not by deriving phi directly, but rather by showing that if the premises are all true, not phi has to be false. And obviously, if not phi is false, then phi is true. So that's why it's called indirect proof. You're not showing that phi is true, you're showing that not phi must be false, which then indirectly implies that phi has to be true. In a little more detail, at some point in a proof, you decide you'd like to be able to derive phi on a line. You can't figure out how, it's not obvious how to do that. So you decide, okay, I'll use indirect proof. What you do is you add an assumption line that consists of the negation of what you're trying to derive. Well, if you're trying to derive phi, your assumption will be not phi. And that's going to be justified as AIP, assumption for indirect proof. Then you proceed using the rules, just like in conditional proof. You would make your ACP assumption and you just proceed using the rules. The difference between indirect proof and conditional proof is in conditional proof, you keep using the rules and you're trying to derive the consequent of the conditional you want. With indirect proof, what you try to derive is an explicit contradiction. Okay, what is an explicit contradiction? I'll show you some examples, but basically it's any statement conjoined to the negation of that same statement. Okay, any one. It could be atomic, it could be P and not P. It could be compound. It could be if X then Y and not if X then Y. So any statement conjoined to the negation of that same statement is an explicit contradiction. That's what you're trying to get. Now, when you derive an explicit contradiction, we know contradictions are always false, right? That's a definition of a contradiction. But we also know that the rules that we're using, the inference and replacement rules, are truth preserving, which means that if we are applying them to true lines, they should only produce true lines. Okay? But we managed to produce something false, the contradiction. We know that's false. How could we produce something false from truth preserving lines? Well, the only way is if something we were applying those rules to was not true. Okay. Well, the only suspect statement is the assumption we added. Everything else is either premise or something we derived from a premise. The only thing that's suspect is our assumption, not phi. So that has to be the thing that's false. Okay. That's the culprit. And if not phi is false, phi has to be true. So once you've derived your explicit contradiction, you've shown that your assumption has to be false, not phi is false, so the negation of that assumption, phi, has to be true. So that's the reasoning. And it'll make a little more sense when we see some examples. So here's a proof. Now, this proof you could pretty easily do without using indirect proof, and you should be able to see that. So I can do conditional exchange on line 2, get not B or not B, do duplication to get not B, and then by modus tollens on 4 and 1, get not A, and there the proof is finished. So you don't need to use indirect proof, but suppose you didn't see that. Suppose you were just looking at the two premises and it didn't occur to you how you could do that. Well, you can use indirect proof. Okay, so I'm going to erase that. You say, well, gosh, I'm trying to get not A. I don't know how to do it. I can't figure it out. I'm going to use indirect proof. What I want is not A. I'm going to assume the opposite. You always assume the opposite of what you want, the negation of what you want. Well, if what I want is not A, then I must going to assume A. And my justification is AIP, assumption for indirect proof. Okay, and just like in conditional proof, I'm going to indent, and I'm going to use an arrow, and that's going to graphically block off my subproof. So when anyone's looking at my proof later, they'll be able to see where the subproof part of it is. Now, my goal is relatively easy. I'm just trying to derive an explicit contradiction. Any explicit contradiction. Let me say this again, because students ask this question over and over, so I want to be clear about it. Any explicit contradiction. Does it have to be A and not A? No, it doesn't have to be. It can be. A and not A is an explicit contradiction, but it could be any explicit contradiction. It could be B and not B. It could be X and not X. X doesn't even show up here. Doesn't matter. If I derive X and not X, that's an explicit contradiction. I can use that to end the subproof. The components of the explicit contradiction don't even have to be atomic statements. It could be X if and only if T and not X if and only if T. That would work too. I could end this subproof with that explicit contradiction. So any explicit contradiction is fine. Okay, I'm just going to try to get any one down, and it's actually pretty quick. You can see here that I've got A. I can do modus ponens on 1 and 3 to get B, and now I can do modus ponens again on 2 and 4 to get not B, and right here on 4 and 5 I've got materials for an explicit contradiction. I've got a statement, and I have the negation of that same statement, so I'm going to conjoin those. I have a statement conjoined to the negation of that same statement. So there, I've got an explicit contradiction. So now I can close my subproof off. And the next line, after I close off an indirect subproof, can only be the negation of my assumption, the AIP. Well, my AIP was A. The negation of that is not A, which is what I wanted. Now the proof is over. Okay, it's finished. Let's see another example. Now, just like in conditional proof, remember with conditional proof, you could derive a conditional. Now the conditional you derive, maybe it's the conclusion, and so as soon as your conditional proof, subproof is over, your proof is over because you derive the conclusion with your subproof. Or you could use the conditional proof to derive something that was a piece you needed to keep going to eventually get the conclusion. That's fine. Same thing with indirect proof. You can use it to derive the conclusion directly. Just assume the negation of the conclusion and derive a contradiction. Or you can use it to derive something you need in order to continue the proof more and then eventually get the conclusion. That's what I'm going to do this time. Now I could just use indirect proof, just assume the negation of the conclusion, not M or K, and then derive a contradiction. Though notice, if I get M by itself or K by itself on a line, I can get M or K by the rule of DI. So that's what I'm going to do this time. I'm going to try and see if I can get M by itself. If I can, then I can get M or K by disjunction introduction. So since what I want to derive is m, I'm going to assume the negation of what I want. I want m, so I'm going to assume not m. And the justification is AIP, assumption for indirect proof. And now my goal, recall, is just to derive a contradiction, any explicit contradiction. And you can see it's going to be pretty easy. Well, maybe you can see that. So I have not m. I can get m or p by di, so I can get k and not l by modus ponens. I'll have then those two components. I'll have k, I'll have not l. When I simplify k off, I'll be able to get l by disjunctive syllogism, and then I'll have l and not l. So that's one way I could get a contradiction. I could also get k and not k. I could simplify not l off, get not k by disjunctive syllogism, have k and not k. There's a lot of contradictions I could get. By the way, that's one thing that makes indirect proof easy, is that if the thing you're trying to derive, in this case m, does validly follow, then when you add the negation of that, the set of statements you have is inconsistent. And when you've got an inconsistent set of statements, it's usually pretty easy to derive anything you want. So it'll be usually pretty easy to derive a contradiction. If you just start applying rules, a contradiction is usually going to pop out pretty soon. You kind of have to work to not get a contradiction within 3 to 6 lines of just random rule application. So it's a very good strategy in that sense. So I've got m. I can get m or p by di on line 3, and now I have the antecedent of line 1. So I can do modus ponens on 1 and 4 to get k and not l. I'm going to simplify k. Actually, I simplify both off. I'm going to simplify k and not l. So I'm going to do simplification on line 5. I'm going to do that twice to get both those conjuncts out on their own. Now I'm going to use not l, okay, line 7. This is the negation of this disjunct, so I can get the other disjunct by ds, so I can get not k. That's by ds. And look, I managed to get materials for a contradiction right here. I've got k and not k. So I can put those two statements together. I've got a statement and the negation of that same statement. So this is an explicit contradiction. So I can close my subproof off. And now I have to write the negation of my AIP. Well, my AIP is not m, so the negation of that is just m. Is the proof over? No, because m isn't the conclusion. But m is something I can quickly use to get the conclusion, because I can just get m or k by di. Notice here that my justification is the entire indirect proof. So like conditional proof, you cite the entire subproof. Okay, let's do one more. So this, recall, was the proof that we did a little while ago in the previous video. And in that proof, we did this not using any subproofs. Recall what we did is we manipulated this until we got if d then I. We manipulated this until we got if I then C. Then we did hypothetical syllogism to get if d then C. Now that was not an easy thing to do. You sort of had to, first you had to know what you were doing strategically. Then you had to do some rule applications. You had to do distribution and some pretty, fancy maneuvers. Subproofs are usually way easier. Students avoid learning how to do conditional and indirect proof because they think it's hard. And it is, it's a new thing to learn. But once you learn it, a lot of proofs get a lot easier. For instance, if you did this with conditional proof, super easy, right? Assume D and then derive C. And you can see how easy that is. If I assume D, well, then I get P and I by modus ponens, simplify I, then I can get I or S by DI, then by modus ponens get C. So it's super easy. You're just using basic inference rules, and it takes like 4 lines, and you can get if D then C. Whereas if you remember doing it without conditional proof, it took like 14 lines, and there was a couple of distributions and a lot of other replacement rules and things like that that were not at all obvious to see. Conditional proof, way easier. But you can also use indirect proof, right? You can use it for anything. I'm trying to derive if D then C, assume the negation. Not if D then C. And now I just have to derive a contradiction. Any old contradiction will work, okay? And you can see it's pretty easy. The first thing I need to do, and this is really the only tricky part of getting the contradiction here, is I have to know that a negated conditional, I can do conditional exchange and then De Morgan's to get some useful pieces out of that. So first I'm going to do conditional exchange, turn the horseshoe into a wedge, negate the first component. Everything else stays the same. The parentheses and the negation come down. I've just manipulated this internal part. Now I'm going to do De Morgan's on this. I'm going to turn the negated disjunction into a conjunction of the negated components. So the outer tilde goes away, wedge becomes a dot, and both components get negated. Not D will become D, C will become not C. And that's by De Morgan's. Now, I can simplify both of those pieces off. I can get D and I can get not C by themselves by simplification on line 5. And the contradiction is going to be really easy here. Because look, I can get modus ponens with 2 and 6. D, and I've got D here, so I can get P and I by modus ponens. Simplify I from line 8, then get I or S, so that'll be this antecedent, and that's by DI on line 9. I goes to I or S. Now that is this antecedent. I can get the consequent by modus ponens, and boom, C and not C right here. There's my explicit contradiction materials. So I'm going to conjoin those, C and not C. And explicit contradiction, next line has to be the negation of my AIP. So it was not D and C. I'm just going to negate it by taking that tilde off, if D then C. And that's by the entire indirect proof, lines 3 through 12 indirect proof. Okay. Now, as with conditional proof, there's rules for using indirect proof, and I want to talk about those right now. So, first one, you start the subproof by indenting and designating the first line AIP. So it's just like conditional proof. The only difference is that instead of ACP, it's AIP, assumption for indirect proof. But you do the same thing with conditional proof. An indirect proof ends only when an explicit contradiction is derived. Okay, that's a difference between this and conditional proof. Conditional proof you can end anytime you want. Right? You could randomly end. You derive lines and you flip a coin, and if your rule is if it comes up heads, you're going to end the conditional proof. If it comes up tails, you're just going to derive a new line. You could do that, and it wouldn't be wrong. Now, depending on when you end it, you might not end up with something useful, right? You might end up with a conditional that isn't going to help you further your proof, okay? But it's not going to be wrong. You can end it anytime you want. It's just only going to be useful for you to end it when you manage to derive the consequent of the conditional you want. With indirect proof, by contrast, you can't end it anytime you want. It has to be an explicit contradiction. Okay, now it can be any explicit contradiction, A and not A, B and not B, some compound statement and the negation of that same compound statement. Doesn't matter. But if it's not an explicit contradiction, it's going to be wrong and you're going to lose points, right? If you just derive the statement Q and decide to end your indirect proof there, that's wrong, because Q by itself is not an explicit contradiction. So this is a difference between IP and CP. Once you've done that, once you're in a position to close your subproof, you mark it off, you draw the little line from the bottom of the contradiction up to the arrow, called closing the subproof, also called discharging the assumption. The next line after that closed indirect proof subproof can only be one thing, can only be the negation of your AIP. That's it. And again, that's good, right? It sounds like a rule, like it's restricting you, but actually that's why you picked the AIP you wanted. You picked the AIP that you used exactly because you knew the negation of that is what you wanted to have. 5 and 6 are the same as with conditional proof. Number 5 is all subproofs have to be closed before the proof can end, just like with conditional proof. So for instance, you couldn't at this point, so this is just the first 6 lines of the example we just did. You couldn't get to here and say, oh wait, I've got K, I can get M or K by DI, and now my proof's over. I derive the conclusion. No, that does not work because I have not closed this subproof yet. And finally, once a subproof has been closed, no lines in it, no individual lines in it may be used or cited. So for example, this is the same example we did earlier. I went up through here, I got M by indirect proof on 3 through 9, and I'm thinking, okay, what can I do next? I'm not sure. Oh, look, I've got K here on line 6. I could get M or K by disjunction introduction. M or K by DI on line 6. No, that doesn't work because here I've cited line 6, but 6 is in a subproof that's been closed. So that would be wrong. Of course, I could get M or K by citing line 10. So in this particular instance, I could do it differently and get full points. But if for some reason I didn't see that or whatever, and I tried to get it this way, that would be wrong. Okay, that's it for section 4.6. Next up is 4.7.